Alright, welcome class. We are going to go ahead and get started into these notes today. We don't have a lot of note taking to take down, just some formulas for area. Areas of parallelograms, triangles, kites, trapezoids, and rhombi. So basically what we're going to do here is our warm-up and jump in and do a bunch of examples, okay? So for the warm-up, number one goes off of what we did yesterday. So we know that they are similar. It tells us that all we have to do is find our scale factor of the larger quadrilateral to the smaller quadrilateral. So that means it shrunk, right? So all we have to do is do the larger number, 2.85. You can pick any side as long as you use the corresponding side. I'm using the tops here. So 2.85 over 1.9. Now when you plug that in the calculator, you get a nice clean decimal of 1.5. So it increased by about 1.5 from the small one to the large one. Okay? The second one here, we got two pentagons that are similar. We have the scale factor given to us. It's 3 over 7. We know the perimeter of the larger one. Now remember, perimeter is also proportional here, so the larger is the 42 on the bottom. We want to find the perimeter of the smaller pentagon, x. So we're going to cross multiply. It's going to be 7x equal to 3 times 42, which is 126. Then we divide by 7 on both sides, and x comes out to be 18. Alright, let's get into these notes. Got a few vocab words to look at. Base of a parallelogram, height of a parallelogram, base of a triangle, height of a triangle, height of a trapezoid. Okay? So here we have our area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. It's true for everything. So our area of a parallelogram is the same formula you would have for a rectangle, as long as you have the height that goes up from one base to the other base, and the base is just the bottom of the parallelogram. So base times height. So let's use that. We also want to find the perimeter here, so we're going to add the sides together. So that's pretty easy. That's pretty easy when you have a parallelogram, because all you have to do is add up all the sides, and we have two of the sides, and parallelograms have opposite sides are congruent. So for the perimeter, we know that one side is 32, the other side is 32, one side is 20, and the side opposite is also 20. So our perimeter is 2 times 32 plus 2 times 20. Same as if you were looking at a rectangle. So 2 times 32 is 64, and 2 times 20 is 40, so our perimeter is 104, and our unit is inches. Okay, now for the area, we need base times height. We don't have our height, but we do know some things about it, right? We have that 12, and we know the diagonal, or hypotenuse of the triangle. You can see, I'll draw it out here. Our triangle here, we know is a right triangle. This is 20, our hypotenuse. We have the smaller side. We want to find the other side of our triangle to get our height. So our height is equal to the square root, using Pythagorean theorem, of 20 squared minus 12 squared. So we're taking the hypotenuse, squaring it, taking away the leg that we do know from it. So height is equal to the square root of 400 minus 144. So our height is the square root of 256, which is 16. So now we have our height. We know our base is the 32. So our area at this point is very easy to find. Just 32 times 16. Punch that in the calculator, and it's 512 inches squared. There we go. Finally got a good 2. All right. Let's move on. Next problem. Another parallelogram. We don't know the height again here. We do know the angle there, S, is 45 though. We know our diagonal is 9. So we have a 45, 45, 90 triangle. We can use that. And we know that when we have the hypotenuse, so our hypotenuse is 9, that means we divide our hypotenuse by square root 2 to get our leg. Or in this case, our height. It's kind of confusing with height and hypotenuse. I don't want to use h yet. So 9 over square root 2, we got to get rid of that square root 2 on the bottom, is 9 square root 2 over 2 after you do all the work. So now we're going to use that as our height. We have our height, we have our base, we just need to find area. So area is equal to base times height. Our base is 12. Our height is 9 square root 2 over 2. So 9 times 12 is 108. Then we divide that by 2, and we get 54 square root 2. We can't really do anything else to it. We'll leave the square root 2 as it is. And we don't give it any units here, so that is our answer, 54 square root 2. Okay, next example. Now we're getting into triangles. Hopefully you've seen area of a triangle before, probably when you were in middle school, probably 7th grade or so. But it is 1/2 base times height, or base times height divided by 2. That's the one I prefer to use, base times height divided by 2. So if there's one more postulate there, the area congruence postulate. If two figures are congruent, then they have the same area. Okay? So area of a triangle, if the area A of a triangle is 1/2 the product of base B and its corresponding height h. So let's do that. So just like before, we aren't always going to be given pieces. Now this one actually goes beyond just finding the area or the perimeter. We need to find those things, but we also need to find out this is a real world situation here. Making a frame for a triangular sandbox shown, and we need to have enough sand to fill it and enough boards to make it. So if one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need to buy? So boards is going to be based off our perimeter. We're going to find our perimeter, divide it by 3. That'll be how many boards we need. The area is going to be number of bags, so we find our area, divide it by 9. That'll give us how many bags we're going to need. So let's do this. Perimeter. Pretty easy here. All we have to do is add all 3 sides. So 16 plus 12 plus 7.5. And when you add all that up, it comes out to be 35.5 feet. Now we are going to divide that by 3. So 35.5 divided by 3 comes out to be 11.8 or so. So we would need 12 bags, or 12 feet, or 12 boards, I mean, to make it. Sorry, I forgot what thing I was talking about. We can't buy a portion of a board, so we gotta buy 12 boards to make our sandbox the way we want it. Now, for the area, it's base times height divided by 2. We are thankfully given our height here, so we don't have to find it. That's the 9. So our base is 12 times 9 divided by 2. 12 times 9 is 108. And 108 divided by 2 is 54. Exactly what we just did on the last problem when we were looking at the first, or the area of that parallelogram. So now we need to take our 54 feet squared, and we're going to divide that by 9. So 54 divided by 9 for square feet per bag, and that gets us 6 bags. So we need to buy 12 boards and 6 bags to make our sandbox and fill it. Okay, area of a trapezoid, here's our formula there. So we got 1/2 the height times the base 1 plus the base 2. So our top and bottom, add them together, multiply by the height, divide by 2. We got our area. So here's a razor that we need to make or find the area for. So we're just going to use the formula straight up. Everything's given to us, the height and the 2 bases. So 1/2, the height's 1, and 1 base is 3, 1 base is 2.5. So 3 plus 2.5, for 1 we can get rid of that 1, because multiplying by 1 isn't going to do anything. And 3 plus 2.5 is 5.5. And we multiply that by 1/2, or divide by 2, either way, and it is 2.75 centimeters squared. Okay, pretty easy. Looking at another trapezoid here, we are given our height, we have our diagonal on the right, and we know our first base. We don't know our other base. We need more information. And we can get that information just like this. Okay, so basically drawing down and seeing that we have this portion missing, right? It's called L here. So we need to find that leg of this triangle that we just made, and then we can use that to find the area with the other base. Basically, you can now see that the top base is 9, right? So this is 9 up here. We don't know our height though. Actually, we do. I take that back. It's 4. It's over there, off to the left. So now we just need to find that little portion to add that to the 9 to get our full bottom base. So we need to use Pythagorean theorem with the 4 and the 5. So 5 squared minus the 4 squared should equal our L squared. So we just square root that. 25 or 5 squared is 25. 4 squared is 16, and 25 minus 16 is 9. The square root of 9 is 3. So that is our L. Okay, so we add that to 9, it's 12, so we have our other base. So our area here is 1/2 the height, which is 4, times 9 plus our other base, which is 12. The 3 plus the 9. 9 plus 12 is 21. And 4 times 21 is 84. And then half of 84 is 42. And that is square feet. Okay, next example. Now we're getting into rhombi and kites. These are actually very, very easy. Multiply 1/2 times the 2 diagonals multiplied together. That's it. So as long as they're given to you, it's very easy to find, right? And we know all these things about them, how congruent they are and how similar they are. Very easy to use. So here's our kite. We are given our 2 diagonals. So our area is equal to 1/2 times our first diagonal, 7, times our second diagonal, 12. 7 times 12 is 84, and half of 84 is still 42. And we are feet, so feet squared. Same exact answer we got on the last problem. Still 42 feet squared. Okay, now the next one is a rhombus We're only given parts of our diagonals, but that's okay. Doesn't make this any more difficult, really, because you can see that it's marked that they are congruent, right? We know they bisect each other, so that's 9 plus 9 is 18, and 7 plus 7 is 14. So that means that one diagonal is 9 plus 9, so 18. The other diagonal is 7 plus 7, so 14. So diagonal 1, 9 plus 9 is 18. Diagonal 2, 7 plus 7, so 14. So now we just use our formula. It's going to be 18 times 14 times 1/2. So when we multiply all this together, our area comes out to be 126 inches squared. Alright, so now we got one more example problem. This one is a bit different. Now we're trying to find what our diagonals are, working backwards basically, if we're given the area. So here's our rhombus. We know the area is 64 square inches. We want to find the diagonals, knowing that one diagonal is half as long as the other diagonal. So that means that we have diagonal 1. We don't know what it is, right? But we know that diagonal 2 is 1/2 of diagonal 1. Okay? We know our area is 64. So what we're going to do is set up our area formula. And plug in what we do know, the area, 64. We don't know what D1 is, but we know D2 is 1/2 of D1, right? So we can plug that in as well. So multiply both sides by 2 to get rid of that outside 1/2. So that's going to be multiplying 64 times 2, it's 128. So then you have two D1s in here, right? D1 times D1 is going to be D1 squared. So we have 1/2 D1 squared. Again, we can multiply by 2, so that's 256 is equal to D1 squared. Then we square root both sides. Gets rid of the square and the square root on the right. So that means our D1 comes out to be 16, because the square root of 256 is 16. And we know that half of that is D2. So 16 divided by 2 is 8, so D2 is 8. And both of these are in inches. There's our answers. Alright, so now your exit ticket is similar to this. You're given the area. You need to find the height of a trapezoid. Sorry, we haven't gotten to our exit ticket yet. This is kind of just a review, again, if you need it, of all the things we just did, what it looks like, how to find the areas for all these polygons, parallelograms, triangles, trapezoids, rhombi, and kites. So we have our area, it's 210. We know the two bases, 10 and 50. We need to find the height and use our formula for the area to work backwards to find the height. Alright? And we'll catch you next time.